Thank you everyone for attending today's presentation. Today I will be taking you through the new automatic fault interpretation workflows that we are introducing in the GVERSE Geophysics 2019.3 release. You can expect the 19.3 update to be available this summer. But before we get into the main presentation, I'd like to briefly go over the main features that are going to be a part of the release this summer. As you can see, fault interpretation is only one of the many features that we are introducing. I hope to do a series of webinars and presentations for each of these features, so stay tuned here to catch up on all the exciting new things we're working on that will be part of 2019.3. One of the big items next release is a brand new, very powerful synthetic package that contains all the workflows that you need for creating and editing synthetics. This includes favorite extraction from seismic data, log curve calibration, estimation, processing, working with deviated synthetics, the whole 9 yards. Then there is, of course, the automatic fault interpretation that I will be showing you today. We are also bringing a major update to our geobody capabilities and providing you with a bunch of features that will make your geobodies really come to life. There is a new cross-plotting tool and an update to our line balancing workflows, picking and editing well tops within the geophysics domain, powerful new additions to our 3D visualization, and of course, like always, many usability enhancements designed to make your workflows more efficient and increase overall productivity. Today's presentation is focused on only the new auto-picking workflows for fault interpretation. To pick your faults automatically, you need a little bit of pre-processing. There is some data prep involved. What I mean by that is that you have to create what we call a fault volume. This is basically a few specialized attributes that we compute in seismic data and then combine them together into a single volume, which helps us identify faults in that data. This is a one-time process, and once generated, you can use this fault volume in any of the interpretations that use the same input seismic volume. So you don't need to create this volume repeatedly. You can do it just once and you're set. Once you have your volume, you then link it to a survey. This is essentially just telling the system, telling your interpretation, which fault volume it must go to when auto-picking faults on a particular survey. After that, you turn on your segment picker or your surface picker and just click on a detected fault, and it will pick the segment or the entire fault surface, depending on which mode you're using, into the active fault. It's as simple as that. We also have a bulk picker, where you just specify a region in terms of inlines, crosslines, and time, and the algorithms automatically go through that subset and try to find all the faults and create fault surfaces for those detected faults, and then display them in your viewer as temporary faults. You can then use all the analysis tools and QC tools like rose diagrams and other tools designed to cut through the clutter of all the faults the system detects and choose which faults actually end up in your interpretation. I'm now going to switch to the actual demo and show you these workflows in action. I have my 3D view open with an inline added to the scene. If I zoom into this area right here, you can see some faulting going on right here. I'm now going to run through the workflows that we discussed in the overview and try and pick these faults automatically. First things first, I must create a fault volume for my data. I can do that in the faults ribbon in the automatic fault interpretation group. I have the generate fault volume option that opens the volume creation dialog. I will select my trace file. This should be seismic amplitude data, and start the generation process. This can take a while depending on the size of the input volume and how heavily faulted that area may be. But like I mentioned earlier, this is a one-time process. This is not something I will have to do every time I want to pick a fault automatically. I can create this volume once and then reuse it as many times as I want to. The creation process also runs outside my main application, so I can continue working and doing other interpretation work while this goes on in the background. Even if I close my interpretation, this will keep running. As long as, of course, your computer is running, that remains a prerequisite. Like for most software, computer needs to be on. But barring that, it is going to run to completion, and once the fault volume is ready, I can then start using it in my interpretation. In the interest of time, I'm going to stop the process now. I already generated the volume earlier before this presentation, and I'm just going to use that to auto-pick my faults. Once I have my fault volume, the next step is to link the fault volume that I just created to the survey I want to pick faults on. I can do that from right here. Just browse to the location of the fault volume and we're done. Now that I've linked a fault volume to this survey, the system knows that when we're trying to run the fault auto picker for the F3 original survey, it must go to this specific fault volume file to get the fault information from. Now we are all set up and we can turn on the fault segment picker to start marking our faults. As soon as I turn on the segment picker, the faults detected are highlighted on my section. It's reading these faults from the fault volume that we specified in the link volume dialog. And as you can see on this inline, these are the faults that were detected in the fault volume, and they are shown here. This works for all sections and orientations. So if I add a time slice here, the faults will show up on that time slice as well. And I can also display any type of data on here, any version of data. Let's switch this to the semblance version, and you can still see the detected faults on top of the data. But these red lines that you see here are not faults that are in my interpretation yet. This is just what the fault volume has detected as faults. I must still pick them to include them in my interpretation as actual interpreted fault surfaces. With the segment pick mode turned on, if I click on any one of these red lines, that detected fault will then be converted into an actual fault segment and added to my active fault. My active fault right now is F1. I'm going to hide this time slice so you can get a better view. Yes, so when I click the detected fault, it creates a fault segment that follows that red line and makes it a part of the fault F1, which is my active fault. Let's move the section 10 inlines in. The detected faults for this section show up, and I can just, with a single click, add the next segment to my fault. Move to the next inline, faults show up, and click to add the segment. We also have a feature now that lets you project faults onto unpicked sections. So I can turn on project faults, and this is going to give me a dotted line on where it thinks the active fault should fall on this next section. This is intended to help you quickly identify which of these detected faults you're after. This feature, projecting faults, also works on regular fault picking. So if you're just doing regular manual fault picking, you can still use the project fault functionality to see where the fault is falling to on the next section. Just one of the many things we've added to try and make your fault interpretation faster and more efficient. Okay, so back to our segment picker. The segments created using the segment auto picker are like regular fault segments. If you don't like what the picker has picked for you, you can always just right click and say edit fault segment. Edit mode is where we can modify a segment. So say you think this segment should have gone all the way up here, you can just move the top node to where you think it needs to be at. I can add nodes, remove nodes. I can also split a segment and automatically created segment, or otherwise, your regular fault segments as well, you can split those as well. You can split the segment and either assign it to a different fault or just remove it altogether. And so you can go on picking your fault segment by segment and adjusting the segments where you think the picker is not doing what you want it to do. If you want to pick the entire fault surface instead of doing it one segment at a time, you can go to the surface auto pick mode. I'm going to switch the active fault to F2. This is the fault I'm going to pick using my surface picker. The workflow is the same. I turn on my surface pick mode, the detected faults show up, I click on one of these lines, and now instead of just picking the segment, it creates the whole fault surface and adds it to the active fault. It creates the surface by adding segments for the length of the fault, and it looks and acts like any other fault that was picked manually. We have a couple of parameters here that let me control the behavior of my surface picker. The spacing setting lets me choose how far apart I want my segments to be, and it's right here. I can also choose the orientations of sections I want my fault to be marked on. This is important because if the fault is roughly parallel to the inline direction, it will not show up very nicely if I pick on inlines or if I try to pick it on inlines. We have a few options here where I can force it to the inline direction or crossline direction, or let the system choose automatically which of the inline or crossline directions it thinks the fault will best show up on. I can also choose an arc line direction, which will just mark segments on arc lines that run perpendicular to the fault plane. You can of course also edit any of these auto-picked segments. Just right click and say edit fault segment. That is going to add the section this particular segment was picked on, and we can do all our editing operations and get the fault to look exactly like you want it to look like. This also works for arc lines. So if you are picking on arc lines and we say view section or edit segment, it will add the arc line it picked the segment on, so we can modify and edit the segment on the exact section it was actually marked on. Alright, so those were the segment and surface auto pickers. We also have a bulk picker that runs through the volume and finds all the faults and automatically creates surfaces for them and then displays them in your viewer. The workflow is different from that of the segment and surface auto pick. The bulk picker outputs what we are calling temporary faults. These are not interpreted faults and cannot really be used in any of your analysis in their temporary state. They need to go through a step of validation where you look at the fault and explicitly convert it to an interpreted fault. This is by design. The objective is to prevent your interpretation from being flooded with faults that you may not actually want in there. It lets you make sure you know exactly what is being added to the interpretation. So how does it work? While you open the bulk pick dialog, you can choose to run the picker on a subset of your volume. So if you have a large survey but you're only working in a small part, or the faulting in your area is limited to a certain area or time range, you can input that here. I've just set this to the bottom southwest corner of my survey. The orientation specifies the azimuth of the faults you want the bulk picker to detect and create fault surfaces for. The minimum height is how big of a fault vertically you want the bulk picker to detect, and then you have the familiar section orientation and separation options that are also available in the surface pick mode. So you set this up and start the bulk pick process. It does its thing where it's going through the volume, finding all the faults and creating fault surfaces that it will eventually display in your scene. The time depends again on the size of the area that you're working in and the number of fault the algorithm encounters in that area. When it's done, all the bulk pick faults, which are, as I mentioned, temporary faults, are added to a fault view. This is like any other 3D view where I can add sections and horizons and all types of data to assist me in analyzing these temp faults and making sure I am happy with them before I convert them into interpreted faults. Now, as you can see, there are a lot of faults here. I can quickly cut through this clutter using some of the interactive tools that we have available. Let's say I've added sections and other data and determined that these few faults that were picked are not to my liking and I don't really need them. Just select them all one by one or draw a box around them and say delete. This will remove these faults forever. You can also conclude that even though the bulk picker picked these 2 or 3 faults as separate faults, they are actually the same fault. Again, select them and say merge. This will merge these faults together into a single fault. Faults that I like and think were picked correctly, I can select and say convert. This will take the selected faults and convert them into interpreted faults. They are now going to show up in my interpretation tree as real faults. For me to use these faults in any meaningful workflow, I must convert them to interpreted faults. We also have a rows diagram that gives you a better picture of what all your faults are doing. All the faults in my interpretation show up in this grid, and as I select a fault, you can see it pop up on the rows diagram. Compass direction on this plot is the azimuth of the selected fault. The radial axis gives you the dip of that fault. You can select more than one fault and all of the selected faults will show up in the rows diagram together. The rows diagram works for temp faults as well. I can switch to show temporary faults and now the grid lists all the temporary faults that I have, that my bulk picker generated. If I say select all, they're all going to be shown on the rows diagram. Since when we ran our bulk picker, we limited our azimuth during the bulk picking process to plus minus 45 degrees. That's what you see here. All the temp faults fall in that range only. The plot is interactive. If I click on a fault here, it becomes unselected, so it disappears from the plot. If I drag my mouse in this shaded zone, I can select faults by azimuth. And this is interacting with my fault view as well. So whatever I select here is visible in the scene. I can then also say I just want to keep these faults that fall in this range and I don't need the rest of these temp faults, I will just invert selection and hit delete. I can also do a batch convert from right here. Just select the faults you want to convert and hit convert. It's going to take each fault and convert it to an interpreted fault. These faults are now available in the interpreted faults section and not the temp faults, since we converted these temp faults to actual interpreted faults that we want to use in our workflows. So this was an overview of the new automatic fault interpretation workflows that are coming out this summer. You can auto-pick segments or create fault surfaces and add them to the interpretation. You can also run a bulk picker to batch create fault surfaces from your fault volume. We have some productivity and analysis tools like the rows diagram, interactive merging and deleting to help you analyze all the faults in your interpretation, temporary or otherwise, and this will hopefully help speed up your fault interpretation process.